Thank you, guys.
Next up, we have Shalyt, who will tell us a little bit about math. So please, if you don't mind, Michael, take it away.
So hi, everyone. Today I'm at the Technion doing AI for mathematical research, but I used to be in cybersecurity for more than a decade. So as they say, once a hacker, always a hacker. Can you see my screen? Yes? I think so. Cool. So I'll show you a few, let's say, weird quirks that we found during our last research, where we were trying to test how good are LLMs in basically integrals, limits, etc. And imagine, a world where in a couple of years you'll be arguing with an LLM about your credit card debt, and if you can convince the LLM that actually the credit card owes you money, that's actually an interesting prospect. So a couple of, I'll start with a couple of simple stuff. So for example, this is a small model, Gamma, open source by DeepMind. So you can ask it, simple math questions, right? 10, 0.9, blah, blah, blah. It gets the right answer, very simple. That's great, not very interesting. But what if we add zeros, right, before the 9 and after the 1, right? Mathematically, it's exactly the same, but actually it changes the result that it returns completely. And now it is false. So that's what that's the kind of logical weaknesses, logical vulnerabilities that we're talking about. You might say, well, but this is a small model, right? 2 billion parameters. Maybe it's just stupid. It can't handle the extra tokens. But actually, even if you go to ChatGPT, this is from a couple of weeks ago, they seem to fix the issue. So ChatGPT, this is GPT-4o. It's not sure either, right? So this is the correct answer, but actually it can also interpret it as a 9.9 minus 9.10, which somehow translates to minus 0.2, which is wrong, in two different ways. First, this is not how math works, and second, even if it did, it would be minus 0.1. Another different example, I'll start going into some slightly more serious math. So we were looking at a bunch of equations and how it how they handle it. So here you give it fairly simple. This is like high school level challenge equation. Maybe I'll make it even bigger. Okay, so you give this equation with some logs, and it thinks for a little while. This is a Gemini 2 Flash, and you get the correct answer. Okay, y equals square root of x, whatever. Well, okay, cool. Now you can go and add to this log base of 2. You can multiply by 1. So, for example, if you just add here multiplication in the base, so that should be just 2 multiplied by 1, which is just 2. Now it crashes and it just gets you let. This is actually reproducible fairly easily, so it's not just a server error. It really is a logical issue. But you can also just represent it differently with C dots. I'll show you how it looks like in a second, right? Sorry, don't need all this stuff. Right, so you just like multiply this, instead of a asterisk with a dot, and now all of a sudden it's understand that, oh yes, of course, it's 2 multiplied by 1, not an issue, gives you back the right result. Well, okay, so you might say, well, yeah, just write correctly the multiplied by 1. But actually, if you go to Grok now, right? So again, the basic version just gives you the correct answer. LLMs are pretty good at math today, which is pretty awesome. But if you, but if you do the same, this C dot, right? This is LaTeX, right? Which is kind of like Markdown for mathematicians and physicists. then it understands it incorrectly. And you can see that this becomes like a 2.1 because it doesn't understand the dot in the right place. And now the answer is, of course, like completely different and not what we meant in the first place. So another example that I want to show. 1 second, I have a cheat sheet of prompts. So this is some other limit. It looks scary, but this is actually something you could get in like 12th grade in high school. So it's not actually complicated. It just looks scary. And maybe you don't remember, but there's actually 1 over sine is there's a name, right? There's a built-in trigonometric function called cosecants, which is literally just defined as 1 over sine. It turns out that there is a difference. So you go to ChatGPT, right? You give it the original version with the sine. It presumably saw sine many times in its training data. So it gets the right result, which is 1 over 150. Details don't matter. Okay, cool. But then you give the version with the cosecants. And now GPT 4.40 thinks it goes to plus infinity, which is very good for your bank account if it goes to plus infinity, right? So this is a few random examples of how you can, let's say, fool LLMs into giving you, let's say, wrong or different answers without changing anything in the mathematical substance underlying right the challenge. Another cool example with the same difference between sine and cosine. So you can do the same with DeepSeek R1, and it gives the right results. Cool, yeah, like 1 over 150. Okay, whatever. And then you can give it the one with the cosecants, and it starts thinking in Chinese. And it goes on reasoning very, very, very long, and everything is in Chinese until spontaneously somewhere around here it stops talking in Chinese mid-sentence and starts talking in English with itself, right? We're talking about its internal thought process. And to its credit, even though the answer is eventually in Chinese, it is correct, right? So perhaps there's some hope to manipulate the way we make the LLMs think internally, just using different names of functions, whether it's giving you different results or just changing the way you think internally.
Thank you very much, Michael. I will have you know that people voted to give you more time 3 times, but at this stage we have to move on to the next person.
Thank you very much.
Thank you so much for all these examples in the math and the Chinese. This is awesome.